And now the 2-1 through 2-5 test.
Thank you, Isaac. All right, so number one, we are solving for h. We need to get h alone. So in order to get h alone, I would first subtract 9 from both sides. Remember, minus 9, I'm going to do plus a negative to remember that that is negative 23. Please don't make mistakes with integers because you're going to be really frustrated with yourself. Although I did see a lot of students had an answer of 50-something, so they did make a mistake with integers. Don't make mistakes with integers. You may use a calculator. Type in your calculator, negative 14 minus 9. So we're testing that you know how to solve equations. We're not testing that you know how to add or subtract integers. Okay? I don't want you to miss a problem because you are doing that incorrectly. Since we're dividing, the inverse would be to multiply, and so you would get h equals negative 69. Done. Okay? Number two, first thing we need to do, we always simplify on either side of the equation before we apply properties of equality. And on the left side, we can add negative 6m and positive 4 and get negative 2. Okay? Again, pay attention to your signs. They mean everything. It's the difference between getting it right and wrong. Negative 20 plus a negative 18 is negative 38. And then I divide both sides by negative 2, and m is 19. Okay? Again, plug and chug to check. It's crazy not to do that. Okay? When I plug these in for m, does it work? Negative 6 times 19 is negative 114. Plus 18 is negative 106. Plus 76, or negative 96, plus 76 is negative 20. So it does check. Okay? And you can plug it into your calculator. Alright, number 3. We need to get m alone. We have m's on both sides, so we need to get them together. Okay, first thing I'm going to do is subtract 6 from both sides. You may or may not have done that. But what happened is this. Now you got two things that were not equal, but there's m's involved. And so since they're both m's, if we do this and subtract 3.2m from both sides, we realize that actually we get 0 equals 2.8m. So then we realize, wait a minute, if I divide by 2.8, we get m equals 0. And then I check it and I go, well, what happens if m is 0? 0 plus 6, is that equal to 0 plus 6? Yes. So that one actually did have a solution. So that's kind of an exception. That's kind of a funky one. But make sure you don't mess up on that. Okay. Number 4, again, we need to get variables together. So if I have 1/6 y, I'm going to add 1/3 y to both sides so I can get my y's together. Let me blow this up a little bit. Okay, so I'm going to add 1/3 y to both sides. And I need a common denominator, so this is going to be 2/6 y. So I get 3/6 y plus 13 equals 7, or 1/2 y, and then I'm going to subtract 13 from both sides. So I get 1/2 y equals negative 6, multiply both sides by the reciprocal, and I get y equals negative 12. Okay, y equals negative 12. Plug and chug to check. 1/6 times negative 12 is negative 2, plus 13 is 11. Does that equal 7? Plus a negative, and that's going to be negative 12 times negative 1/3. So that would be plus 4, and it does work. Okay, so don't forget to check. Use your calculator. Good use of it. 5. The easiest thing to do on this problem would be to just multiply both sides by 5. One thing I saw some of you do is when you multiply both sides by, actually you're going to want to go negative 5. Or, well, we'll do 5. What did you guys do, 5 or negative 5? I made it 5. I made it negative 5.
Oh, wait, no.
Okay, more did negative 5, so we'll do negative 5. Okay, let's see what happens when you do that, though. One thing I noticed is some of you forgot that you have to use a distributive property. So I'm going to distribute that negative 5. When I do that here on the first one, These divide out, and I get a negative 1 times 3. I'm going to do plus and negative here so I don't goof up on the sign. Here I'm going to divide out the 5. Here I get 1 and negative 1, and negative 1 times negative 1 is 1z. And over here I'm going to get negative 3 plus z. So there are a lot of mistakes you can make with signs on this one, so be very conscientious. Now I can subtract z from both sides, and I get negative 3 equals negative 3. And whenever I get something that's exactly equal, and no variable left to solve, then I know it's identity or infinite solutions. Okay? So I would accept identity or infinite solutions. Okay, 6. We always need to simplify before we solve, so we need to distribute on this one first. And then it quickly becomes just like any other problem, plus a negative, so it's negative 7, add 7, and we get 48, and we divide by 6, and y is 8. Okay, pretty straightforward on that one. Number 7. 7, again, we have lots of distributing to do, and I see these signs here that could be trouble for some of you. So again, really pay close attention to that. 2p plus a negative 2 plus negative 14, and then negative times negative is a positive, plus 4p. Now let's do some simplifying. 3p minus 1 equals 6p plus negative 16. We need to get p's together. I'm going to keep my p positive by subtracting 3p from both sides, and I have negative 1 equals 3p plus a negative 16. Then I'm going to add 16 and get 15 equals 3p, so p equals 5. What's so funny? Oh, yeah, okay. Gotcha. All right, number 8. We have a naked negative here, so we need to make sure and distribute it. So it'd be 4x minus 5 equals negative 12x plus a negative 12. I'm going to keep x positive again. Don't forget that negative comes down because that negative goes with the 5, okay? So we're going to get plus a negative, negative 16x plus negative 12. We're going to add 12 to both sides. And then some of you forget that fractions are numbers too, just kind of like x. Kind of like a 0. Divide both sides by negative 16. And x equals negative 7/16. There's no reason to do anything else but leave it like that. Okay? Fractions are numbers. Because this decimal terminates if you put negative 0.4375 or whatever it was, that's okay. But okay, number 9. Would this be a good one to multiply both sides by the LCM? I would. 35, right? Okay, so I'm going to multiply both sides by 35. I'm going to put 2 35s here because when I distribute, I don't want to make a mistake there. I don't want to make a mistake with a sign. And I need to make sure I do it on both sides. That's one other mistake I've seen some of you guys make. Okay? So 35 here, we're going to divide out the 5s and get 1 and 7, 28p. When I distribute it here, we're going to divide out the 7s and get 1 and 5 and get 5 times negative 2 is negative 10p. And over here, we're going to get 270 plus 45 is negative 315. Then we're going to simplify. And then we're going to divide. Okay. Then we're going to divide. And what do we get? Negative 17.5. Okay. So once you get rid of that denominator, pretty basic, but make sure you get rid of the denominator the right way. Okay, number 10. We need to solve for x. So, and then we're going to plug and chug to find some values. So in order to solve for x, I first need to subtract 1 from both sides. Then I need to divide both sides by -2 and get, I'm going to leave it like this. I'll show you why in a minute. Okay? So now, what happens when I plug in -1 for y? I get x equals, when I put in -1 for y, I get -10 and -1 is -11 halves, -11 over -2, which is 5.5. Okay, that's one of your answers. X equals 5.5. When I put in 0, I'm going to get, when I put in 0, I'm going to get 10 times 0 minus 1 over -2. So -1 over -2, which is positive 1/2. And when I put in 3 for y, I get 10 times 3 minus 1 over -2, which is 30 minus 1, 29 over -2, which is negative 14.5 or negative 14.5. Okay, has everybody got that? Solving for a variable, plugging and chugging. We'll have one like that. Okay? Literal equations, you guys love these. I know you guys want more and more and more. I just can't give you enough. So, on number 11, if I'm going to solve for y, this is where I have to use that reverse distributive property. And I know you guys learned that last year, and we've been reviewing it a little bit. But reverse distributing means instead of multiply it through, we're going to divide it out. So what can I divide out of this? Y. What's left when I go xy divided by y? X. What's left when I go negative y divided by y? Minus 1. Okay? Now, if I want to get y alone, I can multiply by whatever's, or divide by whatever's multiplied by it, because that will equal 1. It's a factor. Just like y times 5. I divide both sides by 5. I just dividing both sides by x minus 1. And I get y equals AC over x minus 1. That's it. Nothing else I can do to it. I don't know what A is. I don't know what C is. But if someone did say, what is y if A is this, C is this, x is this, I can do it quickly. So that's the benefit of literal equations. All right, how about the next one? Solve for y. Well, I first need to get y on the same side. So I'd have 3m equals y plus ny minus 6. Then I'm going to add 6 to both sides and get 3m plus 6 equals y plus ny. I see myself having 2 or 3 literal equations, not as many as you had in the practice. But still, you need to know them if you want to get your A. Now I'm going to use the reverse distributive property again. Okay? 3m plus 6 equals y times the quantity of 1 plus n. And then since I did the reverse distributive property, I can go ahead and divide out the 1 plus n, or n plus 1, either way, that's fine. And get my answer of y equals 3m plus 6 over 1 plus n. Okay, so it's still just properties of equality. I have to get my y's together, and then sometimes I have to use the reverse distributive property to be able to isolate it. Okay, which equation is an identity? Well, meaning when I simplify, when are they going to be equal on both sides? Is this one? No. This is going to be 3m minus 3 equals 3m plus 5. So that one's not. This one's going to give you 2w plus 4 equals 4w minus 2w plus 4 when I distribute the negative 2. And then I get 2w plus 4 equals 2w plus 4. Oh, what do you know? Okay? It said which one is. It doesn't say all of them, right? So that implies there's only one right answer, so it's B. All right. How about 14? Which one is an identity? Or no, which one has no solution? So on this one, Is that no solution? Okay. That one was a gimme, I would call. Because if I subtract 6y from both sides, I get 5 equals -3. That's no solution. The rest of them either have one solution or infinite solutions. 15. Define a variable. Okay, first thing I do is I read the problem. Then I underline the important information and circle the question asked. Determine the number of times you must visit the pool to make buying the membership the better deal. If P equals the number of pool visits, because I have to define the variable so I can wrap my head around the problem, what are my two plans? I can either pay 20 bucks, so I want to know when $20 equals $1.35 per visit. Right?
No, when you pay $20, then you get.
Oh, sorry, yes.
20 plus 135.
You're right. Would help if I read the whole problem like I said to do, right? Do as I say, not as I do. Okay. So then we get equals 320p. There we go. Much better. So you get in for a reduced rate if you pay the membership fee versus paying the full rate and not buying the membership fee. Can you guys think of a situation like that? Where you get in, like what? You get in cheaper if you buy a membership? Like where?
YMCA. Well, you can only get in with one.
Well, I mean, like you can buy a guest pass, right?
Yeah, but that's
Or classes. Sometimes classes.
yeah.
Like if you want to be in swimming lessons, you pay a membership fee. Swimming lessons might be $20 a month. If you don't, it might be $50. Okay. Anyways, so we just need to solve for P, right? Subtract $1.35 from both sides, $1.35p. Then we get 185p equals 20. Divide both sides by $1.85 and you get P equals, what is it? Let's do the math. I'm going to use a calculator. Okay, so we have 20 divided by $1.85. Okay, so at 10.8, pretend you can do 10.8 visits. Well, how about 10 visits? At 10 visits, what one's better? Paying per visit, right? At 11 visits, the membership's a better deal. So the answer is 11 visits.
So we go 11.
So 11 visits is the solution. Okay? That would be worth 3 points. One for defining the variable, one for the equation, one for the answer. All right. The formula for the area of a triangle wants you to solve for h. So we could just, if we want to solve for h, we could first multiply both sides by 2 and get 2a equals bh. And then we divide both sides by b, and h equals 2a over b. So now I can do the second question much more easily. Find the height if the area is 45 and the base is 30. Now it's just simple. Plug and chug. 90 divided by 30 is 3. The answer is 3 feet. And, or 3 feet. All right. And the distance formula, I changed this one. It was a harder problem. So I changed this one for you guys. Not that you couldn't handle a harder one, I just like to balance it out. So we have distance equals rate times time, solve for t. So I would divide both sides by r. So distance divided by rate equals time. So distance divided by r equals time. And then it says, if you travel 330 miles, at a rate of 60 miles per hour, how long will it take you to get there? 5.5 hours.
What do you want? I only got this much time. Odds, even, full thing?
Oh, I don't know, what do you
Full to burn?
Probably odds. Okay, what occasion do you get? All right, how many want to see the bonus worked out?
Yeah. Do it.
Okay. We want to solve for y, so I need to get y alone. What do I need to get rid of first?
M.
M, good. Okay, build the burn. So if I multiply both sides by m, I'm going to get KMY minus BFM equals FY. Now I need my y's together because I'm going to need to isolate them. So I could subtract KMY from both sides, and I get negative BFM equals FY minus KMY. Now I'm going to use the reverse distributive property and divide out a y and get F minus KM. And now I can divide both sides by F minus Km because that equals 1, and those are factors, so I can do that. And I get my answer. Negative BFM over F minus Km equals Y. Does that blow your mind a little bit?
Can we have a little easier solve for a bonus one?
I don't know. We'll see. Okay. And to be honest with you, Parker, that's a good question because some people assume that it's just a really hard problem. Sometimes they'll put pretty easy bonuses on there just to make up for a silly mistake. So don't always assume bonus means super hard problem. Okay, so I'm going to show you this on the video so you don't forget. When you go home tonight, I would say if you want to get an A on this test, I'd say for an hour. I'd say an hour is probably about a good amount. Because you don't have homework otherwise. Your homework is a study. So many times we think homework is looking through our binder or, just looking over our notes. You get to use your toolkit. Okay? You need to do problems. You need to be able to do them efficiently and correctly. So the more you practice, the better you're going to be prepared. So remember in classroom, I put 3 things. I don't think we have time. I was going to have you get out the Chromebooks, but I just don't think we have time. So we'll just do Jeopardy together. I was going to have you do Jeopardy on the Chromebooks. But if you go to your algebra class, you will see if you want to work on literal equations, which is, distance formula and things, go to, there should be 3 links. That is really strange. Let me check my other algebra class and see if somehow yours didn't get the same thing, because I want you to have the same as they have. I don't get what happens. What? Let's try it this way. All right, they have all 3, so my bad. I'll make sure you guys get the other one out of yours. So, solving an equation for one variable. So, if those were like the bonus and the other problems, if those are the problems you're having, then this is where you need to go spend your time tonight. Okay? Solving an equation for a variable. Watch the video, pause it, try to do what he's doing. If there's options for additional practice, do it. Okay? All right.